Welcome to the today's LeetCode problem. So today's LeetCode problem is a count largest group, and which is marked as a easy level problem. We will see what is the problem. So we have been given an integer n, and each number from 1 to n is grouped according to their sum of digits. Okay, sum of digits, one thing. Okay, return the number of groups that have largest size. What does it mean? Let's see the test case. We have given n equal to 3, so we have to go from 1 to 13, all numbers, and there are 4 groups having the largest, what to say, digit sum. Okay, group largest size, basically having the largest number of digit sum. So if you see, I will go from 1 to n, that is 13. So if you see, for 1 digit sum is 1, so what I will do, for 1 digit sum I have found the 1. For 2 digit sum is 2, so for 2 digit sum, the key represent the digit sum, I have found the one element, that is 2, correct. For 3, I have found the one element, that is a 3. Instead of this, I can put here the number of elements as well, what to say, the frequency. What I can do, instead of this, I can just replace this, and I can just put here the frequency. Till now I have found one element, makes sense. For 4, I have found one element. Okay, for 5, where the digit sum for 5 is 5 only, so I have found one element. For 6, I have found only one element. For 7, I have found only one element. For 8, I have found only one element. Why? Because there is no other element, okay, or present in our frequency hash map. This is our frequency hash map, frequency hash table, correct. Okay, for 9, I have found only one element. For 10, now for 10, digit sum is nothing but 1 plus 0, that is a 1. So there was already one element, so now the frequency will change from 1 to 2. Okay, for 11, okay, I will just erase this again. For 11, digit sum is 2, 1 plus 1 2, so this will change from here. For 12, the digit sum is 3, so this will become 2. For 13, the digit sum is 4, so it will change. Now what they have asked, this is our frequency hash map looking for digit sum, where key represents the digit sum, that is the 3 shows how many elements are there from 1 to n having the digit sum equal to 3. And what they have asked, return the number of group that have largest size. Largest size means largest frequency. If you see the group, the largest frequency first of all is 2 here, as you can see, 2 2 2 2 and 1 1 1 is there. So I have to just written how many number of keys are there having frequency equal to 2. So if you observe here, this is the one group having value as 2, means frequency as 2. This is second, this is third, and this is fourth, and this is what we have to written here. This is what we are writing here. If you see, for this test case where n is given 1 to 2, that is 2 only, n equal to 2, it means that we have to go from 1 to 2, correct. So for 1, the digit sum is 1, so that is a 1. For 2, the digit sum is again 2, that is only one element I have found so far, right. This shows the frequency. So what is the maximum frequency we have found? That is a 1. How many digit sums are there having frequency equal to 1? That is this one, 2. That's why the output for this case is 2, correct. Now what is our approach to solve this problem? In order to solve this problem, what we are doing, first step, okay, I will just write down here the steps. What we are doing, we are looping from 1 to n, correct. Then what we are doing, we are maintaining frequency hash table, correct. We are maintaining the frequency hash table, which will show me where key is a digit sum and value is a frequency, correct. Third would be, for example, I have one function that is named as digit sum, which takes the num as an input and return the sum, return the sum of digits. We will have to build this function basically. And last I will do find max frequency, and fifth last step will be return count of keys Keys means digit sum, basically digit sum having frequency, that is a value. Okay, value is nothing but I am talking about this. Okay, value equal to max frequency. Very easy, right? So let's analyze what are the constant here. The constant is given n is 10 raised to 4. So if you come here, the time complexity would be 1 to n, that is big of n, and at every step we are counting the digit sum. So digit sum takes at most log n time in worst case. So ultimately the time complexity would be the big O of n log n, which is acceptable because n is given 10 raised to 4, correct? And this will be again the big of n only if there are all distinct elements or all distinct digit sums, which will be the never case, because 1 to 9 numbers are having the frequency equal to 1 only. So if you go to the code, this is my code, okay, and here I am not storing the frequency. What I am doing, I am here actually I am storing the frequency over here. If you see what I am doing, I am just taking the digit sum counts, that is that frequency hash table, max size to maintain the max frequency I have found so far. I am looping from 1 to n plus 1 as it is exclusive. Digit sum, I am just counting the digit sum for the current number I am finding it. I am just incrementing the frequency of the digit sum. If you see here, I am incrementing the frequency, and I am just at every step I am finding the max frequency, that will be the max of max size or frequency of the current digit sum. And finally what I am doing, I have just sum function, Python built-in function, where I am just counting the values, means it returns the key comma val. Okay, so in these values I am just, sorry, not key comma val, my bad, it will just return the values. Okay, I am just checking if value is equal to max size, that is a max frequency. If my current frequency is equal to max frequency, just count plus 1. It is same as running the for loop for key comma val in this digit sum counts, and if v is equal to max frequency, I will just say count plus 1, and we are returning finally the count. It is same thing, but instead of writing 4-5 lines, I have just converted into the single line. So this was the problem and this was the solution for it. I hope you got the solution. See you in the next video. Thank you.